Welcome to Let's Talk Micro.
Hello, everyone. Welcome to another episode of Let's Talk Micro. I hope you enjoyed last week's episode about catalase and coagulase. Before we get started, please remember Let's Talk Micro is available on Spotify, Apple Podcasts, Google Podcasts, Amazon Music, Pandora, TuneIn, Overcast, wherever you listen to your podcast, you can find Let's Talk Micro. I am also on Instagram as Let's Talk Micro, no apostrophe. I'm also on Twitter as Let's Talk Micro 1. So go ahead and follow me. I post a lot of pictures in there about organisms. Last week I posted a picture about a flowchart, a gram-positive cocci flowchart between clusters and chains. Very basic, starting of course with catalase, and then you go depending on the result which way to go. But it gets, you can speciate the flowchart speciates the beta hemolytic streps based on the strep typing, which is what we're gonna be talking about today. It's a great document when you're starting a micro, so go ahead and feel free to print it and use it for your studies. That's the goal here, sharing the information, sharing what I know to make micro a little bit easier for everyone. So every week we do a recap. I'm going to do it briefly. We have a lot to talk about today. So last week we talked about catalase and we talked about coagulase, right? So what is catalase? So catalase is an enzyme that basically catalyzes the release of water and oxygen from hydrogen peroxide. And staph has this enzyme. So this is the first test that we do when we have a gram-positive cocci. We do a catalase. Catalase positive, well, we do a gram stain. And then you have clusters, right? You do a catalase, it's positive. So then you will do the coagulase. Very simple test. You add a drop of hydrogen peroxide on a slide. Then you add your colony and then observe for bubbles. You can also add the colonies to the slide and then add the drop of hydrogen peroxide. What we need to take away from this is that be careful. A positive catalyst reaction, it's supposed to be strong bubbles right away. So sometimes, you can have the enterococcus. It gives you like a weak reaction, maybe 2 seconds in. You see tiny bubbles. This is what's considered a weak positive or a negative reaction. So keep that in mind because if you call it positive, you're going to start going down the line of the staph, and that will be wrong. And then we also talked about coagulase. So this one is used to differentiate between Staph aureus and other staph. So I said that, coagulase is produced by Staph aureus and reacts with fibrinogen, and it results in a precipitation of fibrinogen on the cell, which causes the cells to clump when a bacterial suspension is mixed with plasma. So this test, normally they use some labs might still do it. I don't know other areas of the world, maybe not in the U.S., but it can take a while. It can be a lengthy, time-consuming test. So I talked about the Bacti-Staff kit by Remo, which has that same principle, but it is a very simple test. You add a drop of your latex, and then you put your colony with a stick, and then you mix, and you observe for agglutination. Staph aureus can be so strong that while you're mixing, you can start seeing the reaction. So you should see clumping with a clear background. Maybe tiny particles with a murky background is considered a negative result. But make sure that you read the package insert. As to with any test, make sure that you read the package insert because it says that you can have some false positive reactions, like Staph aureus, um, Staph saprophyticus. So if you get a positive reaction, make sure you correlate that with the morphology, meaning that for you to call it Staph aureus, you need to have beta hemolysis. If it's weak to none, because you can have like weakly hemolytic Staph aureus, then go ahead and perform an ID by another method, like Vitek, Malditov, etc. Do not call it Staph aureus. So the coagulase is used to differentiate Staph aureus from other staph, which we call the CNS, coagulase negative staph. And then your catalase is between staph and strep. Always start with a gram stain first. Always. That's one of the most important tools. So you can actually you perform a catalase on other organisms that are not gram positive cocci. You can use it on gram positive rods. But the flow chart that I released was just for gram-positive cocci. So we do use it for gram-positive rods. The most common species that we use the catalase for are Bacillus, Corynebacterium, Listeria, and Lactobacillus. Now, if you're a student, do you remember the reactions for each of these? Do you? Well, Corynebacterium, it's positive. Listeria is positive. Bacillus is positive. And Lactobacillus, it's negative. So those are four of the most encountered gram-positive rods in the lab. I mean, Listeria to a lesser extent, but definitely Lactobacillus, Corynebacterium, and Bacillus. You definitely work with them a lot. Now that we know about catalase and coagulase, let's talk about the next biochemical, PYR. So what is PYR? PYR has a very long name, and I'm gonna attempt here. We do not mention it in the lab, so we are professionals. So I'm gonna try to read it. So the enzyme L-pyrrolidono acrylamidase hydrolyzes the L-pyrrolidono B-naphthylamide substrate to produce a beta-naphthylamide. That's the principle of the PYR. So this can be detected by adding a reagent and observing a red color. There are a variety of kits out there that you use. You have a disc PYR test, which you moisten a disc with water and then apply the colony. You wait 2 minutes and add your developer. And a pink color is considered a positive result. You can see there's also the identical AE test out there, which is like a little, like cardboard, like a rectangular card. And then you add your colonies, you add your first reagent, you add your colonies, you wait 2 minutes, and then you add your developer. And the same thing, you observe for a pink color. That's considered a reaction, a positive reaction. So yeah, you can have the disc and you can have other methods, but it's always waiting 2 minutes before adding something else. So with the PYR, I always recommend, especially with the students, when you're getting started, because sometimes you're gonna have those iffy reactions, like is it positive, is it not? So you should always go ahead and if you're using the disc and the card or the card, I recommend that you start actually apply your colonies in more than one area. That way, if you have a positive result, you're sure, like you see in the two pink areas. That's a pretty good with those, color reactions. While you're getting, more proficient and while you practice and, you continue doing it and doing it and doing it. It's good to go ahead and apply it on more than one area, and then that way you're sure about your result. So once again, question time for the students. So what is this test used for? First of all, let's start there. Do you remember? Well, by now, if you actually, if you're looking at the picture of the flow chart that I posted last week, so you're doing your catalase, right? So I mentioned catalase positive, you have a staph, catalase negative, gram-positive cocci in chains, you have a strep. So then the next step will be to perform a PYR. So you're gonna have, there are two species that are positive as far as gram-positive cocci in chains. Now, do you remember which ones are those? Enterococcus and Streptococcus pyogenes. They're both positive. And then the other streps like Strep viridans, Strep agalactiae, all the other streps they're negative. So keep that in mind. So that differentiates Enterococcus and Streptococcus pyogenes from other strep. So for the intents and purposes of this flow chart, let's just stick to the PYR on the strep. There are some cases where you can do a PYR for a staph, but let's not go there right now. Let's just stick to the strep. So you have a gram-positive cocci chains. You do your catalase is negative. You do your PYR, and then it's positive. So you can have either Streptococcus pyogenes or Enterococcus. Faecalis, Faecium, Durans, and all those other ones. As far as hemolysis, then you know that Streptococcus pyogenes is beta hemolytic, and then Enterococcus can actually exhibit all three hemolysis. The most common ones are gamma, which is for your Faecalis, and then alpha for your Faecium, your avium. But you can have beta hemolytic Enterococcus. And I will talk a little bit more about Enterococcus once I get through the strep typing. But that's what you use PYR for. So you have a positive, depending on the hemolysis. You have Streptococcus pyogenes, or you can have Enterococcus. There's another test that we use for beta hemolytic strep, which is the strep typing. Have you heard about this? And before we get there, I mentioned that the PYR positive reaction is a pink color, and then no color development is a negative result. Okay, so now let's talk about strep typing. So strep typing is based on the Lancefield group. So this test is used for beta hemolytic strep. So some species of beta hemolytic strep, they have a carbohydrate on their cell wall. Getting technical. So the reagent on that kit reacts with the carbohydrate on that cell wall, producing agglutination. And the Lancefield system classifies the bacteria in groups. You have A for Streptococcus pyogenes, causative agent of the strep throat. You have B, Streptococcus agalactiae, very common seen in meningitis, neonatal sepsis. C, you can have Streptococcus dysgalactiae and Streptococcus aeruginosus. F, you have Streptococcus aeruginosus. And G, you can be either dysgalactiae or aeruginosus. So those are your main Lancefield groups. And this is a very simple test. Once again, the one that I have experience with is the Remo PathoDX. And that one works well with, you have like an extraction. So, which is very basic. You have 3 reagents, and with those reagents, so you basically add 2 drops of reagent 1, 2 drops of reagent 2 to a glass tube. You add your colonies. Don't be afraid to add a healthy amount. And then you add 4 drops of reagent 3. Now, I have seen that I have been in labs where they don't perform the extraction, because by doing that process, you're extracting that antigen from the cell wall. I've seen places that they just add the latex, because the kit comes with the latex for that specific Lancefield, and then they mix their colonies with that, and then they observe for agglutination. In my experience, I mean, I don't like it. I think it's best with the extraction. Even with the extraction, even if you have a smaller amount, it works out beautifully. I have gotten questionable reactions with just using the latex. Like sometimes if you don't have that much, especially like if you're doing, let's say you're doing a urine culture. So most protocols, you have to rule out beta strep between, let's say, like 9 and 49 years of old in females. What's considered a childbearing age. Because, if the female has the beta strep in the vaginal canal, then the baby can get it and the baby can become septic. And it's pretty common, like OB patients. I'm not exactly sure at how many weeks of gestation they get tested for it, for beta strep. So bottom line, you're in the urine bench, maybe you have 2 or 3 colonies. You don't need to do susceptibilities unless the patient is allergic to penicillin. So you have that 1 or 2 colonies, you go ahead and do your extraction, you get your positive result for group B, and then you're done. Report your colony count, and that's it. You don't have to sub it out, you don't have to wait for the next day. That's it, you're done. So that's why I like the extraction procedure. You don't need that much to get that beautiful positive reaction. So like I mentioned, the kit has the 3 reagents, and then it has 5 different latex bottles. One for A, one for B, one for C, one for F, and one for G. And when you're doing the extraction process, where you're doing the 2 drops of 1, 2 drops of 2, add your colonies, 4 drops of 3, you can use that to test for all 5. So one suspension / extraction is good enough for you to test for the 5 antigens. Now, granted, with experience, depending on the source, the morphology, you know what you're looking for, so you can go ahead and, test for the one you're looking for, but this is why you do your PYR first, because that's helpful as well. If you do PYR and it's positive, then you go ahead and just test for A, right? Because you know that CF and G are PYR negative. And then if your organism is PYR negative, then you go ahead and test for your CF and G, but you don't have to test for your A. Then B has also a very distinctive morphology. So a lot of times, you have a PYR negative result, you can just go ahead and, if it doesn't look like B, which is like, it's not as hemolytic as CF and G. It has like the colonies are milky white. So if it doesn't look like that, then go ahead and test for CF and G. I mean, if they're negative, go ahead and test for B as well. So at least, the PYR points you in the right direction. But what you have to be careful also is like this test is for beta hemolytic strep, right? If you look at the flow chart, I mean, you're a microbiologist, you know that some of these species, they can observe all three types of hemolysis. Streptococcus anginosus, which is called the Streptococcus anginosus group, where you have Strep anginosus, Strep intermedius, and Strep constellatus. They can have all three morphologies. They can be alpha, they can be gamma, and they can be beta. But you would only do the typing when they're beta hemolytic. This test is designed for beta hemolytic strep. And like I mentioned before, agglutination, that's a positive result. So the latex in this test is blue. So you're going to see like the blue clumping. Like I mentioned, very simple test. Two colonies, 4, add the colonies to, a card that already comes with a circle, add your latex, mix it, and then rotate for about a minute, and then observe for agglutination. The lack of agglutination is a negative result. So no clumping. That's agglutination. So if you see clumping, it's a positive result. If you don't see clumping, it's a negative result. And since the latex is blue, it's pretty easy to see. Sometimes, follow your package insert. Sometimes, the cards, they need a little bit of a mechanical help. So you can place them on rotator for a little bit. Just always make sure you check the package insert. So that's what a positive versus negative result on a strep typing is. So go ahead and look at the flow chart for the organisms, but I'm going to go ahead and say them again. So group A, Strep pyogenes. Group B, Streptococcus agalactiae. Group C, Streptococcus anginosus or Discalactiae. Group F, Streptococcus anginosus. And Group G, Streptococcus discalactiae and Streptococcus anginosus. So, and that's just based on the Lancefield system. Now, as part of this show, I always like to share what I know, what I have seen while on the lab. So I'm going to tell you something. When you're typing, get your colonies from a blood agar plate. And you microbiologists out there, I mean, you're listening to me say this, and you're like, I know where he's going with this. So yes, like I mentioned earlier, some species of strep, they can observe all three types of hemolysis, meaning that you can have them like a genosis, it can be alpha, it can be beta, and it can be gamma hemolytic. Well, Enterococcus, and this is true of Faecalis, it can observe all three as well, and this is on blood agar. Well, Enterococcus as the whole species, they can observe, they can have the three hemolysis, alpha, beta, and gamma. However, in addition to this, sometimes when you sub Enterococcus to a PEA plate, it can be beta hemolytic. So you have to be careful. And this is why on the labs that I have been at, when you have a PEA plate, people circle the PEA. That way you're aware that while you grow there, you might not be able to test it right away. You might have to sub it to a blood plate. So you find yourself in a situation where you're like, oh, look at beta hemolytic colonies. Let me do a typing. And you might get some agglutination. There was a case years ago where a tech, they went ahead and they saw beta hemolytic colonies on a PEA plate. They did the typing, and it was positive for B. so it was reported as Streptococcus agalactiae. Upon further investigation, it turned out that it was Enterococcus faecalis. So this is where you have to be careful. If you have beta hemolytic colonies on a PEA plate, depending on what the validation has been in your lab, maybe go ahead and perform a MALDI-TOF or another form of ID. If you don't have those, you don't have that many colonies, sub it to a blood plate, because you might be surprised the next day. You have those beta hemolytic colonies on PEA, you sub it to blood, then the next day you're like, oh, this is gamma hemolytic, PYR positive, okay. Then, there's no need to do the typing, because at that point in time, it's gamma hemolytic. PYR positive, what do you have? Enterococcus. So just be careful out there. Remember, if you're reporting Enterococcus versus Streptococcus agalactiae, there's a difference. That can be different treatments. Enterococcus can be, cause nosocomial infections, and they're resistant to that vancomycin. So just be careful. When you have those beta hemolytic colonies, look at your plate. If it's a blood plate, go ahead and test it. So by now you're seeing a little order. So you have your colonies in your plate. You do a gram stain, you see clusters or you see chains. You do a catalase, positive staph, negative Strep. Then if you have a staph, do coagulase, positive, Staph aureus, negative, CNS. If your catalase was negative, PYR, right, positive, look at your hemolysis. If it's alpha and gamma, and this is for gram-positive cocci chains, alpha and gamma, you have Enterococcus. If it's beta hemolytic, you can have Enterococcus or Streptococcus pyogenes. But Streptococcus pyogenes will type A, whereas your Enterococcus, when it's beta hemolytic and you do the typing, will be negative. And then you do your PYR. So if your PYR was positive, you do that. If your PYR was negative, then do your typing. And depending on what Lancefield result you get, those are your probabilities of the species. Now, when I'm saying, like I mentioned on Strep C and G, it can be either anginosus or dysgalactiae. At that point in time, you have to actually either do like a MALDI-TOF or perform an ID to completely speciate it. I mean, you're between those two choices, then you need a formal method of ID to say, okay, it's anginosus or it's dysgalactiae. Anginosus, with the disclaimer that you should never smell plates, it gives like a butterscotch odor to it. So just a little FYI. So there you have it. That's just your basic workup when you have gram-positive cocci in the lab. Now, if you're doing clusters, because that's also the flow chart, catalase negative GBCs in clusters, you do a PYR, it's positive, you probably have an Aerococcus viridans. If it's negative, you have a Aerococcus urinae probably. And then with your chains, PYR negative, alpha or gamma hemolytic, you can have either anginosus or Strep viridans. So, it's a very good flow chart. So go ahead and take the time and, the pictures on Instagram. So go ahead and, take advantage of it. There's some really good information in there. And that, my dear audience, is the end of this episode. I hope you enjoy listening about biochemicals again. PYR and Strep typing. It's been great talking about them. As always, continue providing feedback via Instagram, Twitter. You can go ahead and also review the podcast. Any suggestions, feel free to make them, please. Continue being motivated. Continue bringing that passion into your work. This is an awesome job. I mean, all jobs in healthcare are awesome. I mean, we help the patients. Being a microbiologist is amazing. So go ahead, bring that passion. Let's continue finding out what these bugs are. Let's bring our best into work. I hope you have a great week and continue talking micro. Until next time.